go. Okay. Ready? It's really the last one, so you should be okay. But I noticed that not a lot of people did a lot of code today, so this is really where you're going to get the code. Briefly, so my name is Marechaux. I'm a marketing science lead at Google. I've got a background in math and software engineering and cloud computing, and I'm using that background now for what we call marketing data science within Google. So my team, we are building custom models for specific customers. So basically, they have a business need, and we create models for them, or we create models with them. That's it for me. Now I want to talk about our brains. So if you're familiar with how the brain works, more or less, it's oversimplified. We've got a left part, a left brain, and a right brain. Left is for analytical thinking, and right is mostly for creative thinking. And the reason why I want to talk about that is kind of a follow-up to the session before. I want to make a difference between generative AI, LLMs, and ChatGPT, and everything else, which is one specific branch of AI. But there's also another part of AI, the left part of the screen, which is predictive AI, which is absolutely not related to LLM and Gen AI, and it works. It works for real, and there's a lot of projects in production using old-fashioned AI, so AI from 5 years ago, really old-fashioned stuff. So predictive AI, analyzing and optimizing a word. Generative AI is more creative, being able to create something from an input, a prompt. This is absolutely not related to the presentation today, but I decided to include one slide on responsible AI for every single conference and talk that I do. So I won't really talk about it, but be aware that ethical work in AI is critical. We need, as AI engineers or AI users, we need to be aware of it. So you can take a look at the Montreal Declaration for Responsible Development of AI, or you can go on the Google website for responsible AI as well. And there's others, but AI could be dangerous. AI has an impact on us, humans, on Earth, on a lot of different stuff, so we have to be responsible. And it has to be AI for good. That's it about responsible AI. Probably the only thing to remember from that session, actually, the responsible AI stuff. Agenda. So I will do a lot of demos. Hopefully it's going to be okay on those screens. Otherwise, we'll see. It's going to be related to, as I was saying, my team is doing projects with customers in North America. And what I'm going to show today is really based on what we do with my team. So it's really an extract of our day-to-day work. And as an ML engineer or as a data scientist, you may, or you will, if you are a student, you may have to go through those steps, and maybe you will find it useful. So I'm going to go through data exploration and data viz, ML modeling, which is using old-fashioned predictive AI, the stuff that works, and generative AI. This is more the magic that was mentioned before, which is not magic because it's probabilistic. So it's only not magic stuff. 3 examples, 3 demos. How can you use it on your day-to-day life? It could be for everything that I'm going to use, you can do it tonight or tomorrow morning. Everything is accessible, almost 99% is accessible Everything is free, so you can do it at home on Sunday. It's going to be a beautiful Sunday for you, I'm sure. But if you want to reuse that in a company, I'm using an open data set, but it could be used for very specific stuff in companies like customer churn, user interaction analysis, information instructions in LLMs, in language. And the data is a public data set. So far, so good. Still with me? Nobody left yet, which is good. So, not yet. Let's go and can you see something? Somebody say yes. That's okay. So you see, I'm sorry, I cannot reopen the door. Okay, thanks a lot. So data exploration is one of the stuff that for every single project we have to do first, going through the data that is given to us, try to understand the data. So how many people are using BigQuery? Heard of BigQuery? Okay, I'm going to use, so I'm biased, of course, I work at Google. So I'm going to use BigQuery, but again, there's a lot of open source tools doing the same stuff that I'm going to do. And when I will go outside of BigQuery pretty soon to show you that everything that I'm doing can be done externally with open source tools. But I'm start with BigQuery because this one is very useful. I want to show you a couple of capabilities in BigQuery. So the first one, I've got a table. You don't need to read the table, but I've got a lot of data. I'm only a human. I don't really understand the data that I have in front of me, unfortunately. So there's a way in BigQuery to get data exploration insights pretty quickly. Can you see my cursor? Yeah, you can see it. You can go to the data profile. So I'm not lying. I did something before the meeting to activate that feature, but you can do it as well. You go into data profile, and for the table that I have selected, I have metrics on that table. I did nothing, just clicked a button, and I've got statistical metrics on my data, which is, as a data scientist, it is very useful to start a data science project to understand data trends and everything in my data set. So this is the first thing that you can do. Then, easily, not yet, I want to go into the notebook. That's clear. Let's say I am proficient in SQL. So I know how to write a query in BigQuery. So I will do it. And of course, if you are proficient in SQL as well, you will understand this is a simple query. It goes to a table. The data set that I'm using is a data set for user interaction on a website or an app. So it's every single hit on an app that is, they are captured and sent to BigQuery. So I've got the result of my query. I'm taking some dates and country and so on and so forth. And again, I want to show you another capability. Again, no code for yet, which is good. The chart capability, which is part of BigQuery, it takes the result set and it creates charts with it. So I'm trying to be a bit more clever. I've got purchase revenue, part of my data set. So I want to have information regarding maybe the device repartition. Like I've got desktop and mobile and tablets. This is the revenue that is generated from those three different buckets. Again, I've got no code, nothing to do. It's out of the box from this BigQuery tab. I can also select other, I can select the geo, so it will give me from different continents. the overall revenue. I can see that Oceania is pretty high, which is surprising. So I can go into countries and see from a country point of view the different peaks from different countries. So I can see on this one, because I did it before, I know that this is Australia and Italy and Canada, 3 peaks. So I've got interesting insights out of my data. I've not started anything yet. I've not done any Python code yet, but bear with me, it is coming. So that's cool, but what if I am not proficient in SQL? What can I do? I can do something pretty similar. So we saw just before, oops. Okay, interesting. Okay, I'm going to close a couple of tabs. So we've seen Italy, Australia, Canada as 3 top countries. Let's try again. I'm not proficient in SQL this time, but I know English, more or less. Could be French, could be anything. So instead of using SQL, I've got a query. I'm interested in Australia. Let's say I'm a business analyst. I'm interested in Australia, Canada, and Italy. I want to get numbers, but only for year 2021 because I'm not interested in anything else. So I give a couple of instructions. So let's hope it's going to work. So just copy and paste, and ta-da, magic. This is the LLM magic that you can do. So this is GenAI. I've got a query. I can run it. Hopefully it works. But again, not always. This is LLM. It's probabilistic. So now I've got information on Australia, Canada, Italy, min, max, categories, and the number of purchases for each one of them from a GenAI generated query. So this is another way of exploring data with AI. And real quick, just before, because somebody mentioned that today, I can also do the opposite. I've got a query, a SQL query. It's a complicated query. I'm not really familiar with SQL. I can ask BigQuery to explain the query to me. So I will not read, but it's supposed to be more or less accurate. Again, not always. It takes the query and it says, well, the intent is really to get information from Australia, Canada, and Italy. So it explains the code in plain English to me. So I've got my information to maybe better understand and maybe document the code if I want to. So far, so good? Yes? $4.45? That the 4:45? Okay. I will probably skip one demo. So the demo was extracting 50 million rows from BigQuery and put it in a pandas data frame. So I will skip this one. What do you think? Well, I could do it. Well, know what? Okay. I see the spirit. Okay, so I've got my information. I will not skip anything. We're going to be together until 7 p.m. That's okay. And now, hopefully, I still have access to this. So I'm still within BigQuery. I'm a data scientist. I decide there's a new capability in BigQuery, which is how many people are using notebooks? Okay, so this is a notebook. and it is a notebook within BigQuery. It's not really exciting, but it exists. So I have to talk about it somehow. No, but it could be okay. It could be practical to get everything within BigQuery, within the same environment, whether it is in BigQuery or in Vertex AI, so within the Google Cloud environment. Okay, so I'm in there. Let's say I need to connect. Well, you know what? I don't need to connect because this code works in Collab and in BigQuery Notebook. But in Notebook, I'm within a Google Cloud environment, so I'm already authenticated and connected. So I will specify, can you read a bit, like at a very, very high level? Here I'm specifying my table environment, table dataset project. Then I create a connection. I'm using the BigQuery API. So it could be used externally to Google Cloud or internally as is. I'm connected to BigQuery now. I define a query in there, which is exactly the same query, getting information from my purchases, Italy and Canada and so on and so forth. And now I got some metrics. So within the notebook, it's not rocket science. It's what we do as data scientists. It is really the not exciting part of AI. But that's part of the job. And then I can use open source libraries to be able to go a step further and create graphs out of my queries. So this is the revenue trends for my table, a couple of codes to be able to get the tables, the data, and explore peaks and drops and everything that seems weird, like end of 2020, everything was really lower than before. So this is something that as a data scientist I will have to explain somehow and understand so that my model can learn from it. And also because I'm really interested in Italy and Canada and Australia, I can create a graph with the three of them, and it shows, for instance, that there's something really weird in Australia happening some date, end of 2020. So this is a way to start to identify outliers in my data set with some basic graphs. And I can see the same in Italy a bit earlier. It explained why those different countries were different than the others. So I can use graph for that. Enough for BigQuery. Okay, we've got time. So let's do the full demo then. So the first part, by the way, the notebook will be available in GitHub, so you don't have to remember everything, and you will be able to run it by yourself because it is using almost only accessible data. Demo BigQuery done. Large data set. So let's say I want to run a query that reads a lot of data. So I'm in Collab now, so external to the Google Cloud Platform. So same code than the one that I was using before, but now I need to authenticate. So that's me. Now I should be okay. I'm connected to BigQuery. And I create a query that reads 50 million rows from a table. So this is where we are reaching the limits of the demo. What do you think will happen?
It will work.
Somebody, it will work. It will work, yeah? Someone else?
It's
It is BigQuery. It is. Okay, so everyone is confident it will work. It will take around 42, 52 seconds. So it takes time because there's a lot of rows. I agree. So it started. Anyone else? No? Okay. So let's wait the result. What we can see is that the query is there. So I can see that it has been run. This is today, right? Well, the 14th. Yes. And it took 34 seconds in BigQuery. So you're right. It worked in BigQuery. Actually, it crashed. So this is where I'm reaching the limit of demos. On purpose, I decided to crash my environment, which is not really clever because I still have a lot of demos to do. But to show you that, yeah, it could work in BigQuery, but it does not work in Colab because, well, there's not enough RAM in Colab to be able to run that. The only reason why I wanted to show you a crash, well, first, it's a challenge. Once in a lifetime, you have to crash something, but you know it ahead of time. And then I will play with another library. How many people have heard about BigQuery data frames? 1, 2, 2. That's okay. So BigQuery data frames, the names says it. It's a data frame in BigQuery. I know. Yeah. There's clever people in marketing. It works, we'll see. So the main difference, so again, I have to re-authenticate just in case because I decided to crash my environment before. So I have to redefine the query and the product ID. And now I'm reading, so it's going to take, again, 42 seconds. Always. The answer is always 42. You know it, right? And instead of, so it goes to BigQuery, of course. It goes to BigQuery. But it will not try to create a data set in Colab. The data frame actually is a pointer, is a reference to a BigQuery table. So because of that, because it's only a reference to a temp table that is created in BigQuery, so you can see the query jobs. The first one is it creates a temp table. Then it runs a query and populates the temporary table. And there's other additional jobs. At the end, you're supposed to have a data set. But you will see each time I'm trying to do something with my data set, it goes to BigQuery. So the compute engine, everything that is that I will show you is done actually within BigQuery. And then I've got 5 million rows, so it's going to be long to scroll down. No, just kidding. Only 25 rows, but it says that the table includes 5 million, 50 million. I decided to do it with 50. Why not? Let's be crazy. So yeah, BigQuery data frame, it's another way of using data frame. Don't use it if you don't have a need, but if you are playing with large data sets, maybe it could be useful. It's pretty similar to Pandas data frame, almost, and it's new, so it's going to be similar very soon, but pretty similar, same kind of API. You won't be lost. So now we can go into the second part of the demo. Not yet, I'm lost. Not yet, still this is the first part. I'm sorry about that. So I can read a normal table, like instead of 50 million, it's going to be 5,000 rows. I read it, I've got access to it. It's the same table again. It's analytics metrics from my web app or my mobile app. And it's only focusing on countries and purchase revenue. And again, maybe to close the loop on data exploration, I'm in BigQuery data frame, but I can use those data frames exactly the same way than a regular data frame. So I'm going to use Plotly, which is an open source graph library developed in Montreal. How many people knew that? Uda, that's it. 2? Yeah. And as part of the data science work, I can maybe I want to take a look at some specific metrics. In that case, I'm creating box plot to be able to identify what is happening with my data. For instance, we already talked about Oceania and something weird in there. I can decide to zoom in Asia. I missed it, but I could. Let's go to Europe instead and get a lot of different metrics on my data itself, part of my data exploration work. And it was really to close the loop. And now we are ending part number 1, which is data exploration. And we can go into part number 2, which is how can we create a model from that? Yep.
When you're using the data frames, it's incurring BigQuery cost every time you're interacting with it, right?
Yes. The compute itself will be, absolutely, the compute will be a BigQuery compute. So there's a cost associated to it, which is, I don't know, but you can ask. I'm not really, it's really not expensive.
And you're trending to use partitions more instead of like the limitation of 50 million rows. It's usually the best use practice, right? When you're getting extremely large data.
Yeah, on real project, outside of demo, first, I will not try to crash my environment every time. Second, I will never do a query that, as I showed before, like read 50 million rows from that table, or I put a limit 50, which is in Google Cloud, it's nonsense, but it's for demo purpose. I would use partition to be able to do that. Yeah, so it's a very, very bad example. Everything was bad in that example. Yeah, but I will show you. Well, I'm a data scientist. I'm not a developer, so I can do whatever I want. Okay, let's create a model out of that. This part will not use GenAI because we don't need ChatGPT to be able to do what we are going to do together. The data frame package, it contains 2 different sub-packages. One is pandas. So it's something to be able to create read data, analyze data, and play with data. And it also includes an ML part to be able to do simple machine learning models. So I'm still using the same BigQuery data frame API. I don't remember which one I ran. Okay, I have to focus on code. So I'm still using BigQ data frames, but I could use any other. I could use scikit-learn to do the same stuff. And actually, the BigQuery data frames ML is using some of scikit-learn open source library as well. So again, I will read the same data over and over again. Interaction data, I read it. It goes to BigQuery. There's a cost associated to it. But I don't pay because I do have a Google account, so I don't care. And now I've got access to the different columns, so it shows the different columns that I got in my data set. I will do something, again, very simple. How many people are data scientists or students in data science? Okay, so close your eyes for a minute because it's not, okay, it's a demo, okay? So I've got a data set. I decide to split that data set in two. I put some notes to say it's not a good practice. It's in there. It's a disclaimer. So everything before January 1st, 2021, it's historical data. And because I want the model to run pretty quickly, I only keep the recent data. So recent data, I've got 900 rows in my data set, 8 columns. And now I defined what are the features. So I'm taking the transaction date, the country geo, the device, the OS, and the source. And what I want to do as a model, I want to predict revenue. So based on historical data, I want to be able to predict that somebody that is coming to my website and with from a specific geo, with a specific device and OS, and from a specific source, that person will most likely generate revenue X. So I will do it with an XGBoost regression. And again, I'm going to crash my demo because you don't want to see this for 5 minutes. So this model training will take 5 minutes. So I have to stop it. So it's pretty risky. I'm crashing my demo again. But the result will be something like this. So if you do, well, not if, when you will do it tomorrow at home, it will work. It will take 5 minutes. So go grab a coffee, and you will be able to run that cell, the score, and it will give you a score for your XGB model. The score, I'm going to focus on only one metric to simplify a bit. The R-square matrix. So the R-square for that model is 0.43, which is not, to data scientists, you know it is not optimal. That's a good start. Depending on the context, it's not optimal. So it's a third challenge in my demo. I want to show you something that happens always. You start with very poor model because I've been very, very lazy. I took the different columns from my data set. I did absolutely nothing on those columns, and I decided to call an API to create a model. But it does not work that way in data science. You need to do more advanced work, and this is what we're going to do all together right now. Hopefully it's going to work because I crashed it. So now I'm going to do some feature engineering. So instead of taking and very high level feature engineering, instead of taking the model, the columns as is, I will focus on online data, like interaction, the origin of the data, location, date, and also device and source. I've got another set of feature, which is user behaviors based on browsing activity. And then I decided to include CRM data, so corporate data that I have in my company. I own the website, so I have data on my customers. And it's also to show you that doing lifetime value prediction, it's difficult to do only with online data. Most of the time, you need CRM data. So the query for that, so online data, I'm doing same table, but I'm doing some modification, basic modification on the data. Behavior, same, some modification. CRM data. I've got a table, simple table. I've got the age indication for my customers. I know if they are super user or regular user, or so I've got a level of fidelity for my customers. So I've got a query, and now I can run a model. So instead of using the BigQuery data frames API, XGBoost that I used before, I will use the BigQuery ML API. So I'm calling BigQuery ML from there with the create model statement. I have a lot of variables that I can play with. I decided, so what I'm using for this one is exactly the same set of variable that I was using with the XGBoost before. So I've not done any real tuning on my model yet. And that's it. It uses the query that I created before. And of course, I need to run the cell at some point. Okay. Why did I do? Oh, I know what I did. I did a test yesterday. So I'm trying to create a model that already exists. So now the model runs. It's going to take 5 minutes. So I will crash my model again. I did a test yesterday, so I can show you the result of that model goes into BigQuery. So yesterday was this one. And so some training, I've got some data, and the R square, so we started with 0.43 with very simple feature engineering. I now have a R square of 0.78, which is a good improvement, but it could be even better. It could be better because I could still do a lot of work with my features and my model tuning and so on and so forth. But now it's time to crash it again. When you do it at home, you will be able to get the result and get 78 as well. So just to show you, you cannot really be lazy in data science. You need to do understand the data and do some data transformation. Now it's time to, in the next 5-10 minutes, to do some Gen AI. Yeah. I love the excitement. So what I want to show you, I'm not going to use, so how many people have used ChatGPT? This is a question, well, yeah, forget about it. Okay, you did. So I'm going to do Gen AI, but from within BigQuery, using the BigQuery Gen AI API, which is actually the Vertex API. But there's an API. There's a Google API somewhere that you can use. And this is the one I can use. It has several names depending on what you decide to do. It uses a LLM model that is Text Bison, which is a LLM model for languages. So I'm going to play with it to be able to prompt my model. So again, I'm connected. I've got a table in BigQuery, and that table is a movie review table. I'm connected. The model, I already created it. So basically, I would create a model. When you do it, you have to create a model and run the query. Skipping cells is never a good idea, but I feel lucky today. I am lucky. So this is an example of the reviews from my table. So a lot of text, and it's even more than that, actually. There's a lot of text because it's a review. But because I'm really lazy, I want to use LLM for information, to summarize the information. So what I can do now that I do have a model in that is instantiated in BigQuery, I can use it from my notebook. So I create a prompt. Okay, too lazy. I created a prompt. It goes to a BigQuery model. I can play with the different parameters like temperature and others. And I should have an answer soon. No, this one is quicker. The thing is, you cannot really see the answer. So what it did is, come on. I wanted a summary on the text, so I've got a picture, actually. It's going to be better. And the result is really this. It takes all the text in a table, so it's not a one shot. I went through, in my table I've got I think 54 reviews, but it could be 50, hundreds. It's a data set. I'm going through a data set and I'm applying LLM to a data set. I'm not interacting with a ChatGPT bot. I am using LLM on a data science project with a larger data set. So I've got one example, but the result set is actually 54 answers. Every single review will be summarized with 3 bullet points. Not that impressive because you've done it with ChatGPT many times, but it's within a notebook applied to a data set, so that's cool. But I can do more, of course. I can use, well, what I could do, but I will skip it. Summary again, but a step further. Instead of 3 bullet points, I could ask, well, give me a summary. It's going to be less than 60 words, and I want it, do I have it? Yeah. I want it in French. So it could be French or one of the 40 languages supported by the Google LLM models. Yes?
If you had, say, instead of 60, if you had, say, 60,000 reviews, what kind of architecture would you implement? Like, because you have to implement batch processing, and then you would want to have some kind of agents that keep the sentiment analysis. Like, I don't know how to phrase it.
But I want to go back to the 60. Instead of 60
reviews.
No, it's not 60 reviews. Well, it's 60. Are you talking about this 60 or the other? Okay. No, if it were on a real data set, I don't really have that issue if I'm using BigQuery because it will scale on demand. So it could be 60,000 reviews and it will work the same way. Yes, it will.
Token limit, right? I don't know how much
Well, there's a difference between the token is for every single answer. The token, I've got an answer, I've got a JSON object for every single review. So every single return, there's an API call, a global API call, but every single one will have a result with a token limitation. But there's no token limitation on the global query.
You're making a summary of each individual review, but I'm speaking more in terms of a feedback of sentiment analysis in terms of a business owner. Say, if he wants to do a sentiment analysis on a large data set.
Okay. In that case, I would have to split, and there's already libraries that are doing that. Like each time it's too big for what we're able to do with the tokens right now, you have to split it and reassemble the result.
Yeah, that's what I was
Yeah.
speaking about batch processing. Thank you.
The last demo, I will not run the demo because it's the same. So I take the prompt, copy and paste, run, I've got a result. But the last one is it the last one? Yes. The last one is interesting because it goes to your sentiment analysis example. It's a sentiment analysis example. So I can ask on reviews, it is a positive sentiment or a negative sentiment, which is basically a binary classification. But in that case, I can go a step further with LLM. I can say, go through the reviews and try to identify what is positive regarding the movie itself and what is negative regarding the actors or vice versa. So which means that you can use LLM and I even have another example that is not captured over there. Give me a rating based on that from 1 to 10. So it means that you can use LLM to create data, structured data, out of unstructured data. I've got text, and I can use it to extract within the text itself some interesting stuff like I own a company, I want to get the positive feedback for a positive or negative feedback for a new product, but maybe I want to differentiate the feedback on the product from the feedback on my brand. It is different, and I can use it differently. Maybe the feedback on the product will be bad, but the branding sentiment is still okay. So I can play with LLM in that way to extract data and create new data set, structured data set out of my data. We are almost on time because I want to leave space for questions if you have any. This is probably big enough, I guess. This is a big QR code. It goes to, I wanted to make sure that you can get it, so you get it. It goes to the GitHub repo. The GitHub, it does exist today, but it's empty, so there's a file, but nothing in the file. I will update the file tomorrow or in the next few days, but you can have access to everything in the notebook. Any question, comment? You're tired, you want to get rid of me.